All right, in this video, we're going to talk about the first derivative test for absolute extrema and then use it to redo example 2. Before we jump in, let's just revisit the first derivative test. All right, recall that the first derivative test is to find local maximums and minimums. It is a result or a consequence of the increasing and decreasing test. How does it work? If x equals c is a critical point in the domain, and the derivative f prime changes from positive to negative at x equals c, really like to the right and the left of it, here are positive slopes, here are negative slopes. So that means my function is changing from increasing to decreasing. That looks like a local maximum, possibly an absolute maximum, and the maximum is that function value. Here's another picture. X equals c is a critical point because the derivative is undefined there at that corner, but we still have this case where my derivative is changing from positive slopes, to negative slopes, so my function is changing from increasing to decreasing, must have a max. The max is the y value. If we switch it around and my derivative is changing from negative to positive, in other words, my function is changing from decreasing to increasing, then we've got a min. And here's just another illustration. This is still a minimum value. The derivative doesn't exist at x equals c because of that corner. C is still a critical point. Okay? So let's now tweak this a little bit. All right. Okay. So say x equals c is a critical point, and remember what that means. That means that the derivative is either 0 or undefined. And my function is continuous on its domain. If the function is increasing for all x values less than c, and then decreasing for all x values greater than c, then f of c is going to be an absolute what? Let's draw a picture. And let's just draw one. X equals c is a critical point. My function is increasing for x values less than c. So we're going uphill. Then it's decreasing for x values greater than c. In other words, my first derivative is positive for x values less than c, and then negative slopes for x values greater than c. What does that look like? That looks like a maximum. Now, you might be saying, how is this different than the other one? It's that language for all. Yeah, for all x values less than c and for all x values greater than c, right? So, in other words, my function is always increasing. There's never a place where we're not turning around. Nothing like that is happening after this, because this function is increasing, then decreasing, then increasing again. No, this function is always increasing for x values less than c. Here, x values less than c, and then it's always decreasing for x values greater than c. All right? Now, if instead my function is decreasing, how about this? Decreasing for x values less than c, then increasing for x values greater than c. My first derivative is always negative for x less than c, and then it's always positive for x greater than c. That makes f of c not just a local minimum, but also an absolute minimum. Okay. In our textbook, which I'll pull up here in a second, they don't write it out in English. They just use some inequalities. Okay, let's pull that. All right, if you click on my ebook right here, then it opens up your textbook, and I'm in section, in the chapter 4 section here, and here's the first derivative test for absolute extrema. So it says, suppose C is a critical number or a critical point. Those are all synonyms, critical value. If the first derivative is greater than 0, that means positive for all x values less than C. And then the first derivative is less than 0. In other words, the first derivative is negative for all x values greater than C. Then f of C is going to be an absolute maximum, right? And then the reverse here with absolute minimum. I think that the inequalities can be a little challenging to read, but, you know, to each his own, right? So here, f prime, how about gray? F prime of x is positive. Over here, that's when x on this domain, x less than C. And then the first derivative is negative, less than 0, and that's on this domain, x values greater than C. Okay. This one, first derivative is negative. Those are negative slopes, less than 0. That's on this domain, x less than C. Here, first derivative is positive. Positive means greater than 0, and that's on this domain. X greater than C. Now I will make, here we're looking at a situation, I'm only drawing the one critical point. Now if you had a function, say something like this, where here there are places where for a quick second, those are little horizontal tangents, my function is, its derivative is 0 there. The derivative's also 0 there. But if you did your analysis testing the sign of the first derivative, and you're like, hey, the first derivative is positive, you know, and then positive, so it's increasing, it's increasing, it's constant for a second, then it's increasing again, then it's constant for a second, and then decreasing, constant for a second, and then decreasing and constant for a second, and you considered the function values at these critical points and compared, you could also make a good argument for right here being an absolute maximum, for an example. Okay? Now let's redo example 2 using the first derivative test for absolute extrema. All right, so what did we have? We had our objective function right here, right? We got down to here, our objective function. I'm just going to copy that. Okay, so there's that objective function. I need to find the critical point, and then I need to do a sign test on either side of that critical point and verify that my function is in fact increasing for all x values less than that critical point, and then decreasing for all x values greater than that critical point. So here's a prime. The critical point, which we found already from above, let's just jump right into that. We got W is 600. Right, and so far it's kind of been similar to what we did already, but then instead of looking at this function being continuous on a closed bounded interval and evaluating this objective function at the critical point and at the endpoints. Instead of that, what we're going to do is we're going to do a sign test on the first derivative. Right, so that critical point breaks up the domain. Here's my C, here's my X equals, or we'll just do W, is 600. We've got W values that are less than 600, and then we've got W values that are greater than 600. Because those are the only places, right, we found the only place where my first derivative was 0, and it's never undefined. There's only two options when you put in W numbers into the A prime box. You get undefined, you get 0, you get positive, you get negative. There's no undefineds, there's only one 0, so now there's just these two places in the domain where the first derivative can be either positive or negative. Let's set up our sign test. We have our interval in the domain. Bloop. We have the sign of the first derivative is A prime of W. I'm just going to write A prime. Is it positive or is it negative? That'll tell me if A is increasing or decreasing respectively. Or decreasing. Okay. So here are my intervals. Minus infinity up to 600. And then 600 to positive infinity. Right, those are those intervals. Pick any number less than 600. I don't know, how about 0? If W is 0, we've got A prime is 2400. What do I care about it? I care that A prime is positive, so A must be increasing. Pick a number greater than 600. I don't know, 1,000. Put it in for W. 2400 minus 4,000 is negative. I don't even care what the number is. I just care that it's negative, so A must be decreasing. All right, so there we have it. We found the only critical point, 600. My function is changing from increasing to decreasing at that critical point. In other words, it's looking something like this, increasing to decreasing. My function evaluated at that critical point must be the not just a local max, but in fact the absolute max. And I think the table of values says enough. By the first derivative test for absolute extrema, A of 600, which we went and found in the previous example, is the absolute max area, right? And then you go back and you read the directions and it said, oh, it wanted the whole dimensions. It didn't just want the width and the area. It wanted the length too. You give the length too. Okay? So just for funsies, I'm going to change these to light blue, and that ends this video.